Today we're replacing probably the most famous household HVAC thermostat with its modern copycat version, the Nest 3rd generation. There are other options out there like the new Nest thermostat. I'll link both the options below in the description, but the new one that kind of has that mirror finish, that one can't control systems that have additional stages of heating. So if you have a gas furnace with a heat pump, that needs to switch back and forth depending on the temperature outside. The new Nest thermostat with that shiny front is not going to work, whereas the Nest 3rd generation, which this one costs about $100 more than the new one, this one still has that capability. And I'm actually hoping to integrate this old HVAC system with a new mini split that I'm going to be installing, and I need that second stage in order to use this thermostat to control that. So if you want to see that possible future integration, make sure you hit that subscribe button and click on the bell to turn on notifications. Let's get a quick close-up of this thermostat and just kind of check out how this thing is designed. Pretty amazing how many design aspects they integrated into the Nest thermostat that came from this original Honeywell. Right here, in order to adjust the temperature, we just move this little ring here in the middle. Now obviously Nest, they chose to move the outside ring, but still pretty similar nonetheless. Main controls for heating or cooling, it's just this simple switch over here. So if we switch this one to heating, right there, or if you want to turn our fan to be continuously on, that happens right there. Now to disassemble this, all we have to do is take this outer ring off, like so. And then we can actually see the little vial of mercury in here that makes this thing work. These things are becoming few and far between, and they're not making mercury thermostats anymore. So right now our thermostat is set to about 60 degrees. I'm going to turn it up until the thermostat would come on, which should be about 70. Did you see the mercury roll over? And now we can hear the furnace coming on in the basement. If I turn it back, you can hear that it ramped back down again. We'll pull the thermostat off here in just a minute, but for now let's go ahead and go downstairs and disconnect power at the furnace. Right here is the gas furnace that is powering this system. This is what we need to disconnect power to because the 24 volts for the thermostat comes from this furnace. Right here there is a switch, and we can actually hear the 24 volt transformer shut off typically when we turn the power off to the furnace. So listen closely. There are different types of systems that use either an air handler with an electric heat bank in them, or your air handler or furnace could be up in an attic or in a garage. Depending on the situation, they're going to be in different places. Here in Minnesota, it's almost always going to be in a basement where you need to go and disconnect power. Let's go ahead and take the thermostat off the wall now. There are 3 screws that connect the outer part of the thermostat to the inner. Now if you had a more traditional, like standard digital thermostat, most likely you would just have to grab a hold of the thermostat and just pop it straight off the wall. There's usually not screws involved, but with these older ones they do use screws to attach the 2 halves. Usually it doesn't require like a tremendous amount of force, so if you're pulling on it really hard and it seems not to be coming loose, then just look and see if there are any fasteners that may be involved. Definitely gonna save this thermostat. Maybe someday we'll install it in like a really retro recreation. Now before you disconnect all of the wires, it's a good idea to just go ahead and take a quick picture of what was there before you got started, so in case you need to look back on it or put the old thermostat back in, you can do so. There's a couple of flat screws that are holding the thermostat to the wall. Real quick for the different colors of wire and the terminal markings, we'll start with the R, and that's this red wire coming up here. It's typically red, but it wouldn't have to be. That's the same for all of the colors. The color of the wire doesn't really matter, it's just that most of the time, and logically speaking, it's usually laid out like this. So R is usually the red wire, it comes up, and that actually supplies 24 volts of power to the thermostat. So power's coming up right here on this red wire, And then the thermostat can choose what to do with that power by sending it to different terminals. The first one we're going to talk about is the W, or the white wire typically. That is the terminal for heating. So if the thermostat takes power from the red to the white, it's going to turn on the furnace. The next one is the Y terminal, which is typically yellow, and if the thermostat takes power from the R and puts it on the Y, that's going to turn on your cooling. And then we have this green wire here that's on the G, and if the thermostat takes power from the red to the green or from the R to the G, that's going to turn on the fan, and it's just going to circulate the air in the house without heating or cooling it. Now in many systems, 4 wires is all that you're going to have, but in this case we actually do have a 5th wire, which is really nice, and we're going to be using this blue wire here as the common. Right now it's tied in with the reds downstairs, so essentially this wire right here and this wire right here are a duplicate run. These are both connected to the same place downstairs, so these are both supplying 24 volts to the thermostat. The reason for the 2 separate R terminals, typically it's going to be RH and RC. But the reason that they exist is that on some older systems, the air conditioner had a separate transformer from the furnace. So in most systems, like in this one we're working on today, there's one transformer down in that equipment that we just turned off. But in some older units, there was an extra transformer outside, and so you had to keep the voltages separate, and so you had a separate RC for cooling and RH for heating. In this case, they labeled the RH, and then the other one's just labeled R. Once we get the new thermostat on here, we'll go downstairs and I'll show you what we're going to do to change around the wiring a little bit so that we can use that blue wire as the common. Like I said, not all systems have 5 wires coming up to where your thermostat is located. And if that's the case, you have to decide what you're going to do to basically replace that common wire. Because if you have heating and air conditioning and you want to be able to run your fan, then the minimum number of wires is 4. You need your R, W, Y, and G. If there is no common wire, the thermostat kind of has a problem because it has power coming to the thermostat on that red wire. But if it takes any power from that red wire, it has to be able to have a return path for that power so that it can actually use some of it. Now it is possible to get by with only 4 wires because these companies have come up with a clever way of utilizing a tiny bit of power without actually causing the equipment to turn on. And what they'll do is basically apply a tiny bit from the R to the W, the Y, and the G, because all of those terminals on the furnace control board have little electromagnet relays, and if they apply a small amount of current, it will not close the relay. It won't quite turn on the equipment. And so the thermostat is able to use power stealing to charge itself up. Now that's not an optimal situation. You really don't want to have to rely on it unless you absolutely have to. And that's why in this case it's going to be nice. There's already a 5th wire here we're going to be able to use as the common. But if you don't have the ability to pull a wire, you can either get one of the adapter kits that they sell on Amazon, a link in the description, that allows you to use 4 wires and create a 5th wire. Or if you're okay with it, you can abandon the use of your separately controllable fan, and you can take your G wire or your green wire and move it to the common, and then do the same thing on the furnace control board, and that will allow you to use that as a common wire. You just lose the ability to control the fan separately. Since we already have a picture of this, we'll go ahead and take the rest of our wires off of the thermostat. I found that with these Honeywell ones, they are easier to take off the connections if you just take the screws all the way out, because you can see how they looped the wires all the way around each one of these screws. Now we want to avoid these wires disappearing into the wall, so you can see how I reached behind there and held the wires in place while removing the back plate. We'll just kind of spread these out a little bit so that they don't end up disappearing on us. I guess this Nest back plate is a little bit smaller. One of the benefits of the Nest 3rd generation is that it does come with the back plate. If you buy the cheaper Nest, it does not come with the back plate. So, I don't know, what do you think? Should we put it on there? Yeah, we'll just put it on there for now. I don't have my paint handy, but otherwise I think it looks a lot cleaner without using the back plate if at all possible. This comes with an integrated level, which is really handy. Typically I've found that you can anchor this all without having to add those drywall anchors. As long as you don't over tighten the screws, you'll be fine. I like how they designed this so that you don't have to anchor the cover plate separately. It's just the two screws that hold both layers together at once. Now we're just going to straighten all of our wires out and then clip off most of the excess. We'll probably leave about 1/4 inch of exposed conductor for each of the thermostat wires. These are a pair of Knipex wire strippers. Pretty sad how they got rusty, isn't it? Anyway, one tip that I had learned is that if you put the wire in from the opposite side where it cuts, so right here is the cutting side, so you put the wire in from this side and then line up the insulation where it's flush with this outer edge, you'll end up with a really consistent amount of insulation that is stripped, and in this case it's about the perfect 1/4 or maybe 3/8 of an inch. Now they do include a bunch of stickers that you can use if you would like. Now personally I don't think it's very necessary when you have a one heat, one cool system like this is, but if you have some of these other terminals, it might not be a bad idea to just go ahead and throw these labels on here. Just to point out a couple of these that are more common, O/B is typically going to be for a heat pump of some kind, either a ground source heat pump or an air source heat pump. And then W2 is pretty common in our area for a second stage of heat or for a separate type of heat. So just keep those in mind. Use the stickers if you want to. We're going to skip it in my case. Now we just have to take each one of our wires and insert them in the respective terminals. W1 is for our heating, and then blue is going to be our common, which we're going to go downstairs and hook up here in just a minute so you guys can see what that's all about. And then over on the opposite side we have our Y1 up here at the top. That's going to be for our first stage of cooling, first and only stage of cooling in this case. And then we've got our G right here, that's for our fan. And then over here we have our RH. Now the nifty thing about the Nest is that it's going to automatically jump between the RH and the RC. So if you only had an R or an RH wire previously, so it was just one red wire, you don't have to worry about putting a jumper between these two locations. Our old thermostat, typically you'll see the RC and the RH jumpered right inside of the thermostat, so there'd be a little piece of wire going between right here and right here. In this case, the way this thing was wired, those were technically jumpered, but they were going down on the blue wire and the red wire, and then they were tied together up above the furnace. Alright, that should be it for what we need to do up here for the thermostat location. Before we snap this on the wall though, we're going to go downstairs and I'm going to show you the final wiring connections that we need to make to update the wiring to be using this as the common wire. There's also a common thing that was done to this particular system that can throw people for a loop, which is kind of great that I can show you that example. Most of the time the connections for your thermostat are going to be in the bottom portion of your furnace or air handler. But if you're having trouble locating it, you just look around and find a low voltage wire like this one. This one, it happens to be white, but oftentimes they will be brown. So if we follow this down, you can see it does go into that lower compartment right there. So we'll lift our furnace doors off. And sure enough, right back in there, we can see our connections. If your furnace has heating and air conditioning, most likely there's going to be two separate cables coming in. In this case, we just have one cable, which is interesting because I know that this system has an air conditioner. So most likely these wires are tied together up above the furnace somewhere. So we'll trace the wires here in just a second to see where those all end up. And right there you can see that this is hooked up in a very standard configuration with all of the colors matching their respective terminals with R, W, Y, G, and finally C, which the C is blue, and that's pretty typical actually that is blue. So that should all be correct. Let's go ahead and see if we can find where this wire goes up here in the ceiling joists. So there's our white wire coming over, And sure enough, look right there, we've got a bundle of thermostat wires that were tied together up in the ceiling. So you can see right here, this smaller thermostat wire, that's what goes out to the air conditioner outside. There's typically red and white, which that's what this one is. And what that does is send power to the air conditioning contactor outside. So when there's a call for cooling, it comes down from this brown wire from the thermostat upstairs, and it jumpers over to the yellow wire that goes down to the furnace to tell the furnace that the air conditioner is on, and then out on this red wire to power the contactor. So on the left, this is our wire coming from the furnace, and you can see that these wires are mostly jumpered to the same colors, white to white, green to green, yellow to yellow up there, and then it's also red to red, but it also ties into that blue wire, just like I was saying, how it's jumpered together down here from the RC to the RH. They just jumpered it right here instead of behind the thermostat. So all we need to do for us to have a proper common wire is to take the blue wire out of this bundle and tie it into the common wire coming from the furnace, which is this one right here, which is also going out to the air conditioner outside. So most of the time, all of this stuff would have been done inside of the furnace instead of in this junction right here. But in this case, they just did it up here above the furnace. So all we're doing is taking the blue wire out from right here where it's tied into the reds and putting it with the blue and white wire so that it's integrated into the commons instead of the hot wire. So there, the blue wire is moved over. We can go ahead and re-insulate these, and we should be totally ready to go. If this seems confusing to you, I would encourage you to watch that video that I made before. I'll link it in a card right here about how thermostat wiring works. Once you kind of understand the gist of it, this looks a lot less intimidating. We'll go ahead and throw the door back on. Hey, look at that. Check it out. We found a mouse skull in the furnace. Had to bring that home for the kids. Before we turn the power back on, I'll go ahead and put these covers back in place. One of the reasons is that this right here is a door switch, and if the furnace door isn't on here, nothing will start. And that's actually a common thing. Sometimes we have people that will say, oh, my furnace isn't working. I went down and looked at it, and now it doesn't work anymore. And sometimes that's all it is. I took the door off, not realizing that the door switch disconnected power to the unit. Alright, we'll go ahead and turn this back on, and now we can go upstairs and snap our thermostat onto the wall. Now that all of the wiring details are taken care of, we could go ahead and snap our thermostat onto this plate, and we should be good to go, which we'll do that in a minute. But just to kind of prove how this thing works a little bit more, and to help you kind of visualize what's going on, we're going to recreate what the thermostat is doing without having to have the thermostat do it. So we're going to pull our red wire out that's got our 28 volts on it. It's actually 24 volts nominally. And then we'll take out our white wire as well, and we're just going to cross these two, and we should hear the combustion blower come on the furnace. Yep, that works correctly. Let's go ahead and do it with the G. I'm just going to pull it out a little bit. I'll just kind of stick it into where the copper is showing. Yep, that works perfectly. And I'm not going to do the air conditioner right now because it's cold outside and it could potentially damage the compressor. So we're just going to put that back in there. Now note that if you cross this red wire with the common wire, it's going to blow a little fuse down in the furnace and cause your system not to work. It's typically a little 3 amp fuse. I'll link to a video I did before about that right up here so you guys can see what that furnace fuse looks like. Alright, let's go ahead and connect our thermostat. This is one of the styles that just snaps in position. And when you want to take it off, you just grab a hold and pull it right back off. Since this is just a one heat, one cool system, we really don't need to go through any of the advanced configuration stuff. So I don't think I'm going to make you guys go through all of those steps with me. But if you have more questions about the Nest thermostat, definitely let me know in the comment section down below. Hey, it works. The way this interface works is you just only have to touch the outside ring. This is not a touch screen, so you just rotate it like this to turn it up or down, press it straight in to access additional settings, and then you can go through and configure different things. The fan is one of my favorites to be able to basically set it up. I think I actually have to go into the schedule to do that, but you can set it up where it will run for like 15 minutes per hour. So right here, fan schedule, run the fan for 15 minutes all day long, set, and now it's going to run the fan for 15 minutes per hour. So there's a bunch of different things that you can configure in here, but everything's fairly straightforward. If you had a heat pump, you'd have a little bit more setup to go through, but in this case we don't have that. Of the Nest thermostat options that are out there, the Nest 3rd generation, like we just installed here, is the best option from Google. Now if you want a thermostat that you can geek out a little bit more with and tweaking the settings and making it be exactly as you want it, the Ecobee is a really good option. They've got a lot of configurability, so if you want to nerd out with all the details, that might be a good option to consider. The other thing with the Nest thermostats is that the 3rd generation one that we just put in is the only one that's compatible with the sensors. So if you want to take and use this little sensor in different areas of the house, this is the model that you need. The new thermostat that they just came out with the reflective face, that one is not compatible with those sensors. So just keep that in mind when you're choosing what to buy, in addition to the fact that the nicer thermostat is required for if you have a system with more than one stage of cooling or heating. So I will link all the different options in the description. Personally, if I were to buy another smart thermostat right now today, it would be the Nest 3rd generation, like the one we just installed. I hope you guys found that video to be useful. If you did, hit the thumbs up button. It really helps YouTube know that this video is worth recommending to more people. And let me know, what is your favorite thermostat? Do you like Nest the best? Do you like the cheaper version of the Nest Thermostat E? I know there's a bunch of options out there. If you want a really cost-effective Wi-Fi thermostat, Honeywell makes one that thinks like $100, so there are definitely good options out there. Personally, I like the Nest, and I like that it has a decent number of options for configuration, but it's not so complicated that it's overwhelming to people. Alright, well thanks again for watching. I'll put a couple of videos here on the screen for you guys to choose from if you want to continue learning with me, and we will talk to you guys in the next one.